Hi friends, today we are going to discuss few more questions from the chapter Real Numbers, the first chapter of grade 10 Mathematics. So already we have completed the chapter, discuss all the important topics. Now we are going to the questions. First question, show that exactly one of the numbers n plus 2 or n plus 4 is divisible by 3. Actually, this is a question from Euclid's division lemma, and when we explained that particular topic, few questions we discussed of this particular time. Now, this question, you can see in the question, this divisible by 3. So, what is Euclid's division lemma? If a and b are any two positive integers, then a can be written as bq plus r, where r is 0 less than or equal to r less than b. That is Euclid's division lemma. Now here what you need to do is, in the place of b, put 3. So, and let us take a is equal to n. So the first question answer, n is any positive integer, is equal to 3q plus r, in the form a equal to bq plus r, where what is the variation of r? If this number is 3, then 0 less than or equal to r less than 3. That means r can take the values 0, 1 or 2. So r is equal to 0, 1 or 2. Now, first let us take r is equal to 0. So case 1. Case 1. R is equal to 0. If r is equal to 0, then n will be equal to 3q plus 0 or 3q. If n is equal to 3q, then what is n plus 2? In this case, n plus 2 will be equal to 3q plus 2. 3q plus 2. And n plus 4 will be equal to n plus 4 will be equal to 3q plus 4. So we have written n plus 2 and n plus 4. Which one is divisible by 3? The first one is divisible by 3, whereas these two are not divisible by 3. Now, second case, case 2. In case 2, we are taking the value of r as 1. So, if r is equal to 1, then in that case, n will be equal to 3q plus 1. N is equal to 3q plus 1. In that case, what is n plus 2? N plus 2 is equal to 3q plus 1 plus 2. 3q plus 1 plus 2 is 3q plus 3. So, 3q plus 3, or which is equal to 3 into q plus 1. And what is n plus 4? N plus 4 will be equal to 3q plus 1 plus 4, which is 3q plus 5. So, which one is divisible by 3? Only one out of these is divisible by 3, which is the second one, that is n plus 2. Now, third case, case 3. N is equal to 3q plus 2. R is equal to 2. In that case, n plus 2 will be equal to 3q plus 2 plus 2, which is 3q plus 4. And n plus 4 will be equal to 3q plus 2 plus 4, which is 3q plus 6, which is equal to 3 into q plus 2. So in this, which one is divisible by 3? This is not divisible by 3. This is also not divisible by 3. And the last one, that means n plus 4, 3 times q plus 2 is divisible by 3. So you can see that out of these, in each case, only one out of these is divisible by 3. So that is the proof of the first question. Now let us take the second question. Question number 2. The HCF of 65 and 117 is equal to or can be written as 65m minus 117. Find the value of m. So what is the HCF of 65 and 117? Either you can use Euclid's division algorithm or prime factorization, anything. So if we are using Euclid's division algorithm, 117 is greater than 65, so divide 117 by 65. So we will be able to write 117 is equal to only 1 times 65 into 1 plus 52. 52 is the remainder. So if the remainder is not equal to 0, we need to repeat the procedure. So 65 is equal to again 52 times 1 plus remainder 13. Again 13 is not equal to 0. So 52 is equal to 13 times 4 plus 0. So we got the remainder as 0. So when we get the remainder, the dividend used in that, the divisor used in that step will be the HCF. So here what is the divisor used? 13. So HCF is 13. HCF is equal to 13. But in the question it is mentioned that the HCF can be written in the form 65m minus 170. So 13 is equal to 65m minus 170. So take this here. So 13 plus 117 is equal to 65m. Whether it is 65m is equal to 130, which implies m is equal to 130 divided by 65, which is equal to 2. So the value of m is 2. Now the third question. Find the largest number of 4 digits which is exactly divisible by 12, 15, 18 and 27. So we need to find out the greatest number of 4 digits. Which is the greatest number of 4 digits? 9999, that is 9999. But we don't know whether it is divisible by all these things. Now which is the least number that is divisible by 12, 15, 18 and 27? The least number which is divisible by all these. It is the LCM, least common multiple. So if you find out the LCM of these numbers, that number will be divisible by all these numbers. Then we know that the greatest number of 4 digits is 9999, and divide 9999 by the LCM. So we may get some remainder. Just subtract that remainder from 9999, we will get the answer. So what is the LCM of 12, 15, 18 and 27? We can use any method, prime factorization or any method. So question number 3, LCM of 12, 15, 18 and 27. Now I am not explaining here how to find out the LCM. You have several methods including prime factorization, and the LCM will be equal to 540. LCM will be equal to 540. Now the greatest number of 4 digits is 9999. This is the greatest number of 4 digits. Divide this number by the LCM. So 9999 divided by 540. So if you divide here 540, 9, you get 8 times 4, 3 and you get 279 as the remainder. That you subtract from this. 279. So 9720. So this 9720 is the greatest number of 4 digits which is divisible by these numbers. Is it clear? Now in the next video we will discuss few more important questions from this chapter. So stay tuned with me. Thank you. Bye.